for the first of our student-led Global Change Fellows seminar series of the year. A little bit about who we are. Myself and my colleagues are Global Change Fellows with the USGS Southeast Climate Adaptation Science Center. The CASC is part of a network of climate adaptation science centers across the country that work with natural and cultural resource managers and a variety of other partners to build tools and co-produce knowledge necessary to help fish, ecosystems, and communities adapt to the impacts of a changing climate. Every year, the Southeast CASC at NC State University takes on a small cohort of interdisciplinary student fellows working on climate-related issues to help produce a collaborative space to learn about climate issues and approach impactful grand challenges from an interdisciplinary lens. This is the 10-year anniversary of the Global Change Fellows program at the Southeast CASC, and we're excited to celebrate it with a slate of incredible seminars over the course of the year. For today's virtual format, we ask that you please keep your video off and your microphone muted, such that we avoid distractions. We've reserved time at the end for questions, so please wait until the allotted time to ask questions following the presentations. During the Q&A session, we ask that you please put questions in the chat, and I'll read them aloud to our speakers. I know everyone knows Zoom in today's day and age, but here's just sort of a little bit of a quick refresher, just in case anyone needs to know where things are. One last logistics detail: we do want to know who's in our audience today. We're going to put a quick poll into the chat. I would appreciate participation so we can get a better sense of where our audience is joining us from in the future. There's also a second poll asking about how you found out about this seminar, and we'd ask if you'd fill that out as well so we can make sure we know how to reach folks in the future. Now that we have the logistics out of the way, our topic for today's conversation is demystifying the IPCC report and Code Red on climate change. Our first guest tonight is Susan Hassol. Susan Joy Hassol is the Director of Climate Communication, which we will link in the chat. She's an award-winning climate change communicator and author known for her ability to translate science into English. For 3 decades, she has helped scientists communicate more effectively and provided clear information to policymakers and journalists. Susan is an author of the recently released IPCC report and has written and edited numerous high-level reports, including the first 3 US national climate assessments. She has testified to the US Senate, written an HBO documentary, and writes popular articles, including 2 in the New York Times in recent months. Susan is a recipient of the 2021 Ambassador Award from the American Geophysical Union and an elected fellow of the American Association for the Advancement of Science for exceptional contributions to the communication of science change policy to policymakers and the public. Her Twitter is @ClimateComms, and without further ado, we'll give it over to you, Susan.
Thanks. Thanks, Ben. So let's see. If you want me to share my screen, somebody else has to stop sharing theirs. Let's see. Okay. Everything look okay?
Looks great.
Great. Okay. Well, I'm really glad to be with you all tonight to help demystify this recent IPCC report on which I'm one of the authors. IPCC, let's see, I'm having trouble making the slides advance. Let's see if I try this way. Here we go. IPCC was established in 1988, and the first report came out in 1990. The one that just came out is the 6th assessment report. It assessed 14,000 scientific publications. And the author team is gigantic from all over the world, 234 authors from 65 countries, and a huge review process. So the good thing is the tremendous participation from scientists all over the world. The downside is because it's such a large author team and it's a consensus process, sometimes you get a very conservative outcome, kind of a lowest common denominator of what everybody can agree on. But in the past, when IPCC lead authors get together, it looks like this. You can see me there in the turquoise sweater in the middle. We were in Exeter in the UK. This was for the IPCC report on 1.5 degrees of warming. But of course, in the recent year, the lead author meetings look like this. And what I've done is taken this 1,300-page, very technical report and boiled it down to what I think the 5 takeaway messages are. And that's what I'm going to talk to you about. So number 1, it is unequivocal that human activities are what's driving global warming. And IPCC gave us this handy chart this is a simplified version that they put in the summary for policymakers. The gray bar in the gray box there, that's the observed warming. And the red bar in the red box is the total human influence. And so what you can see here is that the human influence on climate is the same as the amount of observed warming. In other words, we're causing all of it, all of the warming. Some people have the sense that maybe this is natural and we're contributing a little bit to it. And that's not actually the case. They also break down the two parts of the human influence. The bigger red bar there is greenhouse gases, the heat trapping gases, carbon dioxide, methane, nitrous oxide, and the blue bar is sulfate aerosols and other tiny particles, aerosols not to be confused with spray cans, but the tiny particles we get from burning high sulfur coal, for example, those screen out some of the sunlight and provide a bit of a cooling influence. So that cooling offsets part of the warming, which gives us this net warming. So if anybody's confused about this, all of the warming that we've seen so far is due to human activity. What are these human activities? It sounds like such a vague term. Well, it's burning of fossil fuels, coal, oil, and gas in power plants, in transportation, cars, planes, and so on, and the clearing of forests, and also agriculture. So those are the human activities that are causing global warming. These are the emissions, the heat trapping greenhouse gas emissions. And I like to call them heat trapping gases because not everyone understands the metaphor of the greenhouse. And heat trapping tells you what they do. They trap heat. So 62% of the problem is due to CO2 from fossil fuels, 11% CO2 from the clearing of forests, 3% roughly is cement and other CO2 chemicals. And then we've got methane, that's about 16%. And nitrous oxide, 6%, mostly from agriculture. Methane is divided between agriculture and fossil fuel emissions. When we use so-called natural gas, which is methane gas, some of it leaks, and that's about half of that piece of the pie chart. And so that's the basic breakdown. So I said it's unequivocal that human activities are driving global warming, and they are causing, and it is causing, widespread and unprecedented changes in our atmosphere, oceans, land, cryosphere. That's all the frozen parts. That's the ice, the snow, the permafrost, and the biosphere. That's all the living things. And these are some of the changes that are being caused. We know that everything in white is going up, higher air temperatures, higher ocean temperatures, higher sea surface temperatures, water vapor, temperatures over land. And then there are a few things going down, as you would expect in a warming world: glaciers and ice sheets, snow cover, and sea ice. Now, the second big take-home message from this report is that human-caused climate change is exacerbating extreme weather in every region. Now, this is really important because most of us don't experience climate change as the slow, gradual increase in the global average temperature. Nobody lives in the global average. The way most of us are experiencing climate change is through extreme weather events. Some of the changes in extreme weather that the IPCC report talks about and assessed: extreme heat. Those are the big heat waves like the one we had in the Pacific Northwest this summer. They are becoming more frequent and more intense. Heavy rainfall. A warmer atmosphere holds more moisture. So when a storm system comes through, that rain dumps out in heavy events. We get less of the light events and much more of the very heavy events. Those are more frequent and more intense. All of this is happening in every region around the globe, and we've got observations to show that. Drought in some regions, especially the very dry regions, are getting drier. So the US Southwest is an example of that. The Mediterranean is another, and those droughts are getting longer and deeper. Fire weather. When you have more drought and you have more heat and you don't have as much rain, or when you get the rain, it's in heavy events, you tend to have more fire weather. We're seeing more frequent fires. We're seeing larger fires in the US. Almost all the largest fires have been over the last couple of years. So hurricanes, the big one for the US, big one for the Southeast. The hurricanes are more intense because they get their energy from warm ocean water. And most of the energy, the excess heat that's trapped in the Earth's system because of these heat trapping gases, has gone into the oceans. More than 90% of that energy is in the oceans. So hurricanes get their energy from the warm ocean water. They're becoming more intense. And so we're seeing fewer of category 1 and 2s, but more category 4 and 5s. Also, these hurricanes are carrying more rain. And so we get the very heavy flooding that lasts for a long time in some cases, because some of these storms are stalling in place, rapidly intensifying, and we're getting more rain. And most of the damage in hurricanes comes from flooding. So that's some of the extreme weather exacerbations that we're seeing because of global warming. Point number 3, we are now on track to exceed 1.5 degrees Celsius, which is 2.7 degrees Fahrenheit of warming by 2040. And that's about a decade earlier than previous projections. So that means more and stronger impacts sooner. And you can see here in the gray bar, the near term, that's 2030 and 2040. And you can see that under any of these scenarios, even under the lowest of these scenarios, we would hit that 1.5C, 2.7F mark in just less than 20 years. So right around the corner. Point 4, it is not too late to act to immediately and rapidly reduce emissions and avoid the most damaging effects. So sometimes people see this science and they think, you know, it's too late. There's nothing we can do, but there's a lot we can do. And it means, though, very rapid changes in our energy system and in preserving our forests, and some of our agricultural practices need to be adjusted. So these are 5 emissions scenarios, and these lines show carbon dioxide emissions in these 5 different scenarios, from very low to very high. And these are the temperatures that would result from those emission scenarios. So you can see this very close correspondence between, you know, the lower the emissions, the lower the temperature increases, and the higher the emissions, the higher the temperature increases. And the second part of this statement, that, you know, it's not too late to rapidly reduce emissions and avoid the worst and most damaging effects. However, changes to some things, the oceans, ice sheets, and sea level, will continue for centuries, but how much they change is still in our hands. So ocean temperatures are increasing. As I mentioned, so much of the excess energy, more than 90%, trapped in Earth's system by our emissions of these heat-trapping gases, has gone into the oceans. And oceans hold that heat. Water holds heat for a longer time than air. And so that will stay for a long time. And because the oceans are warming, they're increasing the sea level. That's one of the ways sea level increases. The other way sea level increases is the melting of ice on land. So the Greenland ice sheet, the Antarctic ice sheet, and mountain glaciers in every region, those are all melting and losing mass. That's adding more water to the oceans. So there's the thermal expansion because the oceans are warmer, they're taking up more space, and there's the addition of the water from land-based ice, and that's also increasing sea level. The rise in sea level will continue for millennia, but how much it rises is still in our hands. Lower emissions, less temperature rise, less sea level rise. And of course, in a state like North Carolina, which stands to lose a tremendous amount of land due to sea level rise, that's very, very important. The fifth take-home point, and I feel like this is very important to say, every ton of emissions adds to warming, and every increment of warming matters in terms of the impacts. So let's start with every bit of emissions adds to warming. I showed you this, I'll show you again here. The lower the emissions, the less warming there is. So it really matters. Sometimes people hear about, oh, it's going to warm somewhere between 1.5 and 4.5 degrees Celsius. And they think that it's just a crapshoot, you know, or it's like throwing a dart, and it depends if we're lucky or not. It's not that at all. If our emissions are lower, the temperature rise will be lower and all the impacts will be less. So it really is in our hands. And the second part of the statement, and every increment of warming matters in terms of impacts. So one way of looking at that, the IPCC shows us these 3 graphics. And the first one is temperature rise at 1.5 degrees Celsius, in the middle at 2 degrees, and on the right at 4 degrees. And of course, the Fahrenheit numbers are much larger. So what you can see is it's a very different world. So every degree of warming, every increment of warming makes a difference, because when we get these increases in the average temperature, we also get much larger increases in some regions, like the far north, like the Arctic. And then we also get much worse heat waves and all of the other kinds of impacts that I talked about, all the types of extreme weather. We see more of that, and it's worse at the higher temperatures. So that's why we want to try and keep this. And the Paris Climate Agreement is to try and stabilize global warming at no more than 1.5 degrees Celsius increase from pre-industrial levels. So that's the goal. And here, this is what happens with precipitation change. In green is the increases in precipitation, and the different percentages in brown, the decreases. And so what you see again is at higher temperatures, the wet gets a lot wetter and the dry gets a lot drier. And there are some places like the Southwest US and Mexico and the Mediterranean that would dry out so much, a 40% decrease in precipitation in places that are already very dry. So it's really, really problematic. So as we say in the IPCC report, the climate we experience in the future depends on our decisions now. The climate system has some inertia to it, right? This is like a giant tanker, and we can't turn it on a dime. We have to start turning it now, because it's going to take a while for the climate system to respond. Also, our economic systems have inertia in them. We build power plants. They go for 40 years. So anything we build now, it's going to have a lifetime. So we have to be really thoughtful about that. Now, you probably heard that the UN Secretary General called this report Code Red for Humanity. Well, what does that mean? I think we all know what Code Red means. It means we need to take action, and we need to take it now. There's no more time to kick the can down the road, right? This is now unprecedented. There are some aspects of it that are irreversible, but how much comes in the future is up to us. And we have to make decisions now. This is a critical year. This is a critical decade. And the decisions we make and the actions we take in this decade will determine what happens for the decades to come. So that's what Code Red means, and it's a pretty serious comment. Now, it does not mean, however, that if we pass that 1.5 degree mark, that we're screwed. So I liken it to, we're on the CO2 highway. Now, if you're on the highway and you pass your exit, what do? You slow down and you take the next exit. And that's what we're going to have to do here, because every increment matters. So if we pass that 1.5 degree exit, we're going to slow down and we're going to get off at the very next exit that we can. So this isn't like a cliff we fall off of. This is a gradual process, and we need to do as much as we can, as fast as we can. And that's the most important thing for us to do. So rather than going to read that whole 1,300 pages, you might just try and remember these 5 key takeaways. Human activities are what's driving global warming. It's already exacerbating extreme weather globally, including here at home. We are on track to exceed the 1.5 degrees Celsius goal by 2040. It's not too late to avoid the most damaging effects, and every increment of warming matters in terms of impacts. So the future really is in our hands. And with that, I will stop, and follow me on Twitter if you're on there. I have a lot of fun with Twitter these days. I tweet at ClimateComms, and I will stop sharing my screen and turn it back over to you, Ben. Thanks.
Thank you. That was an incredible presentation. Our next guest today is going to be Rebecca Ward. Rebecca works at the NC State Climate Office Center and works on delivering climate extension education to a variety of audiences, working with various sectors in the state to provide climate data and information to support decision-making. Recently, she has worked closely with NC State Extension and NC Cooperative Extension to deliver climate-focused workshops and to develop decision-supported tools that incorporate climate data and expertise to inform planting and management decisions for agricultural crops. Previously, she was an active member of the NC Drought Management Advisory Council, helping to monitor drought conditions across the state, and worked on several research projects to explore and analyze new drought indicators and indices and systematically develop and evaluate new informational resources to communicate current drought information. She holds a bachelor's degree in meteorology and applied mathematics, a master's in atmospheric science, and is currently working towards her PhD in science education, all from NC State University. Thank you so much for being here, Rebecca. You have the floor.
Thank you. And I'm very excited to be able to be on this panel tonight with Susan, who is kind of a rock star. So I'm really excited about this. So jumping in, what I wanted to talk about is, what does this mean for the Southeast, trying to bring it home. I have just one quick slide. I think that was a really good introduction to talk about the type of work I do at the State Climate Office. I'll just leave this up here, but say if anyone is curious about the Climate Office, there is our website right there. My work tends to specifically have a very big agricultural focus, so a lot of my time is spent thinking about agriculture and climate change. My work is also very North Carolina centric, so doesn't mean I don't think about the Southeast. It's important to be aware of our neighbors and what's going on, but I just please be forgiving tonight if some of my examples are a little bit North Carolina centric. So jumping in, so what does this latest report mean for the Southeast US? So kind of what Susan just mentioned, right? When I read through the report, the two things that I came away with, in addition to those 5 key points, but was that the science about what we know in terms of how our climate is changing, what's causing it, what are those global changes, what are those regional changes, what are the types of impacts that we're already seeing and that we're projected to see, and how do we solve this, right? What kind of mitigation do we need to prevent the worst future climate scenarios? There wasn't anything there that was brand new scientific knowledge, right? We're just getting a lot more certain. But the thing that really struck me was the language in the report itself, really emphasizing that certainty and really emphasizing the urgency. And this has really been picked up a lot by the news media, that the time to get our act together globally and do something is now. And so while I have the floor, I wanted to highlight what are some of those changes and impacts we're seeing in the Southeast, but keep that pretty quick and high level. And then focus on what are some of those actions. What are states and communities doing in the Southeast around mitigation and adaptation? And how does this fit into that bigger picture of really addressing this code red message that we need to act now? So first, thinking about the changes and the impacts, there was a really great summary that Susan just gave, so I won't go back into it and rehash it here. I'll just cover it by saying that climate change is really intensifying the water cycle on the planet. So we're already seeing an increase in extreme precipitation in the Southeast. Our hurricanes are becoming wetter, they're becoming more intense overall. We're seeing sea level rise, and we're seeing this appear really readily, especially on North Carolina's coast. I had the opportunity to travel over to Alligator River National Wildlife Refuge 2 months ago, and I was shocked at seeing visibly just how much sea level rise was present and apparent, and how much of a concern it was in the day-to-day activities of the folks there. Our temperatures are warming, and that warming has been more pronounced at night. As our temperatures warm, that risk for extreme heat increases, and that's the #1 weather-related killer in the United States. So it's something that we really have to worry about too in terms of health impacts. And then with warmer temperatures, we see more evaporation and increasing soil drying between rain events. Our risks for droughts as a result could be increasing. And all else being equal, when we see future droughts in the Southeast, they're going to be warmer, which means that they're going to be more severe than they've historically been. And then lastly, increased wildfire risk is also going to be a consequence. It already is a consequence. When we see that warmer temperatures, more evaporation, increases that severity. It also leads to fewer days where we can actually do prescribed burns, which has been the primary way that we manage forests for wildfire in the Southeast US. So all of these factors and impacts exist in the Southeast, and they all interact together. We have sea level rise, and that can compound the influence of storm surge when we have a hurricane. When we have a severe drought, that can make the severity of wildfires, if they form during a drought, make them that much more intense. We have seen and will see hurricanes followed by droughts, followed by more hurricanes. And then through all of this, we have other factors. The Southeast has a growing population. We have increasing urbanization. And then thinking about the combination of hazards and social factors, we're all going to be impacted, but some people will certainly be impacted more than others. And what's really struck me when this new report came out was how much more prominent climate change and connecting events to climate change has become in just the popular media. So I did just a quick search this morning to see, how easy would it be to find, an article kind of coming to each of these topics, and it wasn't difficult at all to find something that's been reported on by local news organizations or things like the New York Times on these different types of weather extremes that we're seeing and how climate change is playing a role in intensifying them. So there's more than just these impacts, but I don't want to spend a lot more time on this because what I really wanted to think about is, well, this is what's going to happen, but what's our agency? What can we do and what's happening? This slide we just saw with this figure, thinking about if the causes of global warming are emissions of heat trapping gases, primarily carbon dioxide from the burning of fossil fuels like coal, oil, methane gas. To solve this means we need to cut back on those emissions. And the sooner we cut back, the less warming we'll have in the future. So what's happening, sorry, I'm trying to get my mouse here. So what's happening in the Southeast in terms of mitigating climate change? So I really want to spend most of my remaining time just kind of hitting across some of the things that I'm aware of that are happening across the Southeast. It's not meant to be comprehensive, but just to highlight what's going on. So the first thing, and sorry, I told you this was going to have a bit of a North Carolina lean, is thinking about what are the types of policy actions that are going to be necessary at all levels of government to really bring about the types of changes that we need to reduce our global emissions. So this is one in North Carolina back in 2018. Our governor signed an executive order to reduce our state's greenhouse gas emissions by 40% below 2005 levels. And as part of this, all state agencies are conducting assessments of their climate change needs and vulnerabilities. And there's really been quite a bit of momentum to do the work to increase the resilience of the state, such as through the state's infrastructure to make it, build it up so that when we see the next Hurricane Florence, we don't have our highways shut down for days. Thinking, kind of pulling out and looking more broadly at the Southeast, and I'm apologizing that that image isn't loading on my screen. This map is from the US Climate Alliance, looking at states that are part of the US Climate Alliance, which North Carolina is, as is Puerto Rico in the Southeast. Elsewhere, it is a little bit less exciting, but I did want to mention Puerto Rico because when I was looking at this, I was intrigued by the fact that it also has a 50% clean energy target. And this to me is just another good example of how we need to have policies also driving the momentum towards changing our energy and makeup. So in 2019, Puerto Rico's governor signed a bill into law that calls for 40% of Puerto Rico's electricity to come from renewables by 2025 and 100% by 2050. And then, related to that aim is to make the island more resilient to future storms through having, instead of just one central or a couple of central power generation, to have more distributed generation through microgrids. Currently, not much of the grid is supplied by renewables there. I looked up from the US Energy Information Administration, which estimates about 2.5% came from renewables in 2020. So there's a pretty big road to take. And some recent articles I've come across highlight some of these challenges that are happening in terms of offshore fuel companies, which currently supply that energy generation, not necessarily wanting to be put to the side in favor of renewables. I think that gets to the inertia that was mentioned earlier with we have inertia in the climate system, but we also have inertia in just sort of our economic systems and our political systems and making this change happen. Other types of thinking about electricity and switching over our energy grid towards renewables as a way to reduce greenhouse gas emissions in the nation and in the Southeast is through things like solar energy. And we're pretty sunny in the Southeast, and there's a lot of growing interest here. There's a lot of current federal rebates, looking at like rooftop solar. I know that that's something that, like, even personally, I've been looking at because it's finally kind of cost. The cost has really come down because of federal programs and our local utilities supporting it as well. But one other great example is looking at more microgridding across the Southeast and really the US and the globe. In North Carolina, the electric cooperatives are partnering with communities and businesses, such as in this example with Rose Farms, to develop microgrids to produce that electricity locally, so that they can offset some of those emissions, but also to be resilient when there's power loss, such as for the storm, or just because we're having challenges with generating electricity from those other sources. As I mentioned earlier, I work a lot with agriculture. And so lately I've been really thinking a lot about what are the solutions that exist in agriculture. And some of the things that come to mind immediately are that forests can hold and store carbon for long periods of time. So restoring forests, planting forests have a lot of potential for carbon storage. Additionally, agricultural practices that really improve the quality of the soil in the fields can also help store carbon. The capacity of the soils in the Southeast to store carbon is a little bit lower than it is in other parts. I think Nebraska has a much higher soil carbon storage capacity. And I don't really understand the chemistry and the physics behind that. But what I have been really interested in are recent studies, such as this link I just pulled up here on the bottom, looking at ways that we can look at agriculture holistically, especially when it comes to livestock practices, from managing the pastures to be able to store more of that carbon in the ground, but also thinking about what are different feed that we can give to livestock so that they're producing less methane, which again is another very potent greenhouse gas. It looks like another one of my images didn't show up. Oh, that's frustrating. So I think this is my last mitigation example, just again, kind of giving a quick hit, is looking at how can we sequester carbon in geologic formations underground. This one I find really intriguing because it kind of brings to mind this idea of, we're going to kind of engineer our way and as a solution. And so South Carolina, which you can't see there, is just a screenshot I took from the South Carolina Department of Natural Resources work they're doing to explore the feasibility of storing carbon in geologic layers underground. I also came across this article from Southerly on the right that I took a screen capture of. It's in Louisiana, but it was talking about how oil companies in Louisiana are also looking at can they store carbon that they capture in underground geologic layers in the ground. And so I found these interesting because to me, it really brought to mind this idea of how do we reduce emissions? What does it mean to be storing carbon in the ground? Does that mean that we can continue emitting if we're storing? How does that balance out? Because I think that there's a lot of nuance there, and I have personal opinions on it, but I thought it was a good thought-provoking article and research that's happening. And then lastly, I didn't want to leave without mentioning adaptation, since I recognize that I'm giving this talk for the Southeast Climate Adaptation Science Center. So the climate is changing, and no matter what that emission pathway is, right, we're going to be experiencing impacts. And so we're going to have to adapt to those changes. And that adaptation can happen from the individual level all the way really to the national level. And thinking about what the adaptation is necessary to foster resilience in the face of climate change really is going to depend on what are those hazards that we are facing. So I just pulled two quick examples that I knew of. There are many more out there. Most of them in the Southeast that I've seen are happening kind of at the smaller scale, a city or a town really working on it. In North Carolina, the Resilient Coastal Communities Program is facilitating community-driven resilience goal setting and capacity building, focusing mostly on resilience to coastal hazards. And then the second on the right is Resilient 305, which is in Miami-Dade County, a partnership between the county, the city of Miami, and the city of Miami Beach. Again, looking at resilience to climate change, but also holistically, also including things like economics or labor market shortages. Yeah, and then the last thing I was thinking about, which I think maybe is better for discussion, is how can the people who are in this room, the Zoom room tonight, what is our role to play in terms of, what can we do? What's our agency? So I just jotted down 4 things. One being elevating climate change as a topic in your day-to-day conversations. If it's not present, then we can ignore it. And so making it something that's important to you and talking about frequently can decrease that apathy. If you are a communicator about climate or climate change, talking about those actions and really making sure that you're sharing meaningful actions at a collective level, ones that will actually make a difference. If you're a student or a researcher, we need you. This really takes a lot of cross-disciplinary research because the problem's cross-disciplines. And then lastly, that we also have the capacity as individuals to be part of that action. So I think that's it. Just links, those articles that we can share, and I'll stop there. Thank you.
Great. Thank you so much, Rebecca. And thank you again, Susan. Given that this is just such an important topic for us to talk about, and given that we have 2 experts here, we really want to get going on that Q&A session. We have some questions already flowing into the chat. Reminder that if you have a question for either Susan or Rebecca or both, please throw that in the chat and I will read them out loud. So our first one is going to be, what do you make of when people say that we should not interpret extreme weather events as climate change? For instance, in Cameroon, where I came from, there has been records of 2 snow events in the last 12 months in some communities in the Northwest and West regions of the country. This is unusual for a tropical African country. And that's from Michael. Thank you, Michael.
Yeah, I'll take that to start, and Rebecca can chime in if she has more to say. So I put a link in the chat that I think is going to be really helpful for everybody. They're called quick facts. We originally designed them for journalists, but they're great for anybody. And there's one on climate change and heat waves, and there's one on climate change and heavy rain and flooding, and climate change and hurricanes. And each case, we took all the science and summarized it in some plain language points. We know there are very strong connections between climate change and heat waves. In a hotter world, you get longer, hotter heat waves. IPCC shows this in a lot of detail. And the things I told you in my talk about these various types of extreme weather and how they're affected by climate change. Now, with snowstorms, that's a little trickier. In general, we're seeing less snow, more rain. We're seeing less cold. However, that's based on some things that we can model very well. There are other things that we can't model very well. And some of those are, for example, the change in the jet stream. We're seeing changes in atmospheric weather patterns and atmospheric currents that seem to be related to climate change. So for example, when you warm up the Arctic a lot, the Arctic is warming twice as fast as the planet as a whole, you get a lot of melting of sea ice and snow cover, and that changes the dynamic. So what drives the jet stream is the difference in temperature around the equator and the poles. But because we're warming the Arctic faster, we're reducing that temperature difference between the equator and the poles. That makes the jet stream move slower and it gets wavier, and you get these dips of cold air that come down. And so we see snow in places we're not really used to seeing it. It's related to climate change. It's very difficult to model. So the science is still developing on this, and it's not as pinned down as some of these other things that are very much basic physics. So I don't know what to say about those particular instances that you're talking about. There may be some specific event attribution studies that might be able to shed more light. The problem is with those event attribution studies, they're based on climate models. And if the models can't capture something, then the answer that they come out with is going to be an underrepresentation of the real effect of climate change. So it's a tricky one.
Great, here we can move on to the next question then. This is aimed at Susan, but anyone can answer. I think we talked about this a little bit in the chat, or there was a little bit of conversation in the chat, but the inertia that many companies have with regard to making change to reduce their climate change impact have to do with shareholders' demands for quarterly growth. Do you believe our economic framework holds us back? Do we need to, as a society, rethink the way we view economic growth to combat climate change? Thank you, Ethan, for that question.
Yeah, it's a really great question. And I would start by, I'll try and take it in two different directions. I would start by saying it's difficult to have infinite growth on a finite planet. And yet that's the way our system is set up, for infinite growth. We also tend to be sort of materialistic as a society. And so we place a lot of value on things, and we don't place as much value as we should on the things that really matter. What really matters to me is time with family, time with friends, time in nature, time to make art and make music. Those things are not, they don't have like a material value generally. So I think that we could have lives that are actually much richer in all the things that really matter. And those wouldn't be things that add to our gross domestic product. So that's one thing I would say. The other thing I would say, though, is that we sometimes think that we need to sacrifice and suffer to address climate change, that we have to give up everything that we want. And I actually think that's a fallacy. I don't think we have to choose between a good life and the things we want and a good climate. So I think that that's just a fallacy. And the reason I think it is this: technology, it can really help in this regard. What technologies we're using to create energy. So we don't want coal, oil, or gas. What we want is cold beer and hot showers. If we can get the cold beer and hot showers with solar power and geothermal energy and wind energy, then we're happy. We don't necessarily want a car that runs on gas. What we want is mobility. And so if we have better mass transit, if we have better bicycle paths, if we have other ways to get around, if we have electric cars for those times when we need cars, and that electricity is all coming from renewable energy, we can have the mobility we need. So my sense is that we can have a really good life. We can have all the things that we want and need. We just have to use sustainable technologies to get there.
Rebecca, this one's a little bit more Southeast focused, so it might be a better fit for you. We often think of the Southeast US as a moisture-rich environment, at least in comparison to the Western US. What questions do water resource managers in the Southeast United States have regarding climate change? What are the anticipated impacts to regional water resource management in the coming decades?
Yeah, that's a good question. I haven't interacted with every water resource manager, but the things that I have heard are we do get droughts in the Southeast, and we are going to see more droughts. And so the same things that we've had to deal with in the past with increasing population and demand for that water, dealing with that in a changing climate, though that's not going to change in the future. We might have to deal with increased evaporation from those surface reservoirs for using them. In coastal areas, thinking about increased saltwater intrusion into aquifers if we're using well water, so full water for drinking out of the ground is also a concern. And then there's flooding. We've seen lots of flooding recently from hurricanes that have impacted the Southeast, and thinking about dams that have failed. So how do we make sure our infrastructure is able to hold up to future events when it's aging? And we continue to need it for flood control, and we continue to need it to hold water that we use for drinking.
Great, thank you. Next question is, when we're considering the replacement of coal and gas with alternatives, what are your thoughts on biofuels in that they're still carbon-based? Do you have any thoughts on anaerobic digestion-derived biogas? And how do you see that in comparison to natural gas?
Rebecca, you want to start on that?
I would say, I'm actually not very familiar with the pros and cons of biofuels, so I will pass. Yeah.
I would say that there are some real downsides so far to what we're seeing with a lot of biofuels. So I think we have to be very, very careful. It seems like there might be some better ways. We just, I would point people to Project Drawdown, which does really thorough evaluations of various types of climate solutions. And I think you'll get more from them. Also, so natural gas, I try not to call it natural gas because I think that's just a marketing term because it makes it sound cleaner and more natural. It's methane, it's fossil gas. And right now, the way that we're deriving most of the hydrogen is by reforming natural gas, and that's not good. It's a brown hydrogen. If you want to have green hydrogen, you have to make it with renewable energy. And so if you use renewable energy to split water and get your hydrogen that way, then it's great. And we can use it as a replacement for methane gas or fossil gas in some applications. And I think for some things that require that electricity isn't good for, say, long haul flights. Short haul flights, electricity looks to be pretty good, but long haul flights, probably not. So there are some things we're going to need to use hydrogen for. And as long as we get it the right way, then it's fine. I don't know enough about this particular process that was being asked about. I know there are some ways to turn animal waste into a usable fuel. And if we can do that, I think it's a good idea because we get a lot of methane production from animal waste when it's just sitting around.
That's great, thank you. What are some of the opportunities to improve climate science communication to at-risk communities globally and in the Southeast US?
So I would just say one thing that's really important in communicating about climate change with anyone. We want to understand what people care about, and then we can talk to them about how climate change is affecting those things that they care about, right? So we want to connect on values, and we want to, so if I know that somebody loves to fish, I can explain that climate change is warming the streams and the cold water trout that you're used to fishing for are dying off. So I find some way to connect with a person on something they care about. And look, everybody cares about their children. So talking about the climate and the future that we're leaving for our kids is important. I think a lot of people want to know what they can do. And so I think it's important for us to figure out how to talk about that. So Rebecca told you some of the things that each individual can do. And there's been a lot of talk around the carbon footprint. And certainly it makes sense to walk or bike instead of drive, to try and live car free, to buy green energy for your home. And if you can't put solar panels on your roof because maybe you're a renter or you live in the woods, you can buy into a shared program, community solar, a lot of utilities have. And that's what I buy into, is that kind of a program. So there are lots of things like that you can do in your own individual life. But then there's something larger, and we might think of it as our climate shadow. And that is, what do you do to make a difference? What do you do in the wider world to invest in companies that do the right thing and not spend your money with companies who do the wrong thing, to encourage other larger systemic action on climate change? So I think that's a really important piece of this, is that we should work on those larger systemic changes that we know we need to make. So you could do this, for example, by trying to get your town to do better, have better bike paths. and or to commit to the city buying clean energy, going to 100% renewable energy. So there are things you can do where you live, getting your university to divest from fossil fuels, all kinds of things that we can do in our lives that are more broad than just our individual carbon footprint.
Yeah, and I everything that Susan just said, I would just add that if you're trying to communicate with an at-risk community, is to be careful about putting the onus of solving climate change on their shoulders, and really thinking about what's the bigger picture, right? What are the things that we can do collectively? Important to emphasize the individual actions and things that they can do, but really thinking about the bigger picture and who we can support and who we can sort of call out for contributing to climate change.
Yeah, it's really important. Most of the at-risk communities have not contributed as much to the problem of climate change, and yet they are often hurt first and worst by the impacts of climate change. So I think that's why there's so much in the Build Back Better Act, as much as we'll hopefully be able to be retained in it, that is to try and help at-risk communities especially, and to make sure that some of the dollars, a good part of the dollars spent, are spent there, and trying to protect at-risk communities. So agreed.
Great. Does the IPCC or other planning consider the negative warming effects of renewable resources such as hydropower?
The negative warming, I'm not sure I understood. Say that again. The negative
here. Does the IPCC or other planning consider the negative warming effects on renewable resources such as hydropower?
Oh, I see what you're saying. Yeah. So, right. If in a warmer world, you're going to get more evaporation of water, that may be reducing the hydropower resources in some places. So yes, absolutely. So I should say about IPCC that it's 3 separate working groups. Working group 1 is the report that just came out. That's the physical science basis. Working group 2 is impacts and adaptation. And working group 3 is mitigation. And mitigation is where they deal with things like the kind of energy that we're going to use that's going to be carbon free. So this first working group did not deal with that question. But yes, IPCC and other people who analyze these things do look at how climate change will affect the renewable resources that we use. And it's very important because there will be some downsides in that regard, and there'll be some upsides as well. So yeah, it's really important to look at those things.
This is probably going to have to be our last question, unfortunately, just given time. But Kate asks, in recommendations coming out of the UN Biodiversity Conference, some nations are planning on meeting about 30% of their carbon goals via conservation. Can you speak to this, and is it viable?
Conservation of, like, conserving land, conserving forests. I think maybe that was the intent. I think that there are some countries where it's very, very important to maintain intact tropical forests, for example. And so if those countries are planning to meet some of their climate goals by really conserving their forests, that's great. That's what we want. We need to stop clearing forests. We need to plant more trees, but we especially need to stop cutting down the ones that we have. So I also think it's very important to think about the biodiversity crisis and the climate crisis in unison. They're very interrelated, and we need to make sure that we're protecting biodiversity at the same time as we're protecting climate. And often they go hand in hand. You know, if you protect the tropical forests, you're protecting biodiversity and you're protecting climate at the same time.
Well, great. We are unfortunately out of time, and I did want to just mention that the results of our polls showed that most folks were from NC State University and university affiliated, which is to be expected. And it looks like our CASC newsletter is an effective way to reach folks. So with that being said, I did want to let you guys all know about the next seminar that we are going to be putting on. That's titled Stories of Culture and Adaptation on November 2nd. That's going to be featuring EPA Administrator Michael Regan and Queen Quet, who's the chiefess of the Gullah Geechee Nation, as well as other incredible guests. And hopefully you guys are able to make it. They really put together a rock star cast to talk about a lot of cultural issues when it relates to climate change. And we'll be continuing to put on these as the year progresses. But thank you again for the two presenters here, as well as everyone who showed up. This is a great group of people, and clearly something that people really care about, as can be reflected by the number of questions and the amount of engagement. But thank you so much.
Hey, Ben, if there's time for one more quick answer. I saw a question in the chat, and I really feel strongly about it, so I wanted to respond to it. I agree with the questioner that the goals for individual action should be on legislative change and system change, not on individual action. And putting the onus on individuals is something that the fossil fuel companies would really like for us to do. They would really like for us to think this is our fault. This is way too big a problem to solve individually with voluntary action. We need system change. We need to phase out the use of fossil fuels as quickly as possible. And that is where the focus of individuals should be, is on making those system changes. So I just had to say that because it's such an important subject. Thank you.
Yeah, great. Thank you guys. And hopefully we'll see everyone on November 2nd. We recorded this, so we'll be able to send it out to anyone who wasn't able to make it. But thanks again, everyone.
Thanks all.